Aloha everybody, this is Gigi from Kauai Community College. In this video, we will be talking about the conditional statement with their associated converse, inverse, and contrapositive. So hold on to those thoughts in terms of what those are. What we're going to do first is we are going to go ahead and make some predictions and see how our predictions get tested out, right? So there are two pairs of equivalent statements here. Make your best guess. Fill in the blank below. First statement is if P then Q. The second statement is when I switch the order, if Q then P. Are those equivalent? The third is when I negate both P and Q. So if not P, then not Q. And then the fourth one, you got it. I am going to switch that order. If not P, then not Q. So which pair are equivalent? And there are two pairs of equivalent statements here. Go ahead and pause the video and write down your prediction. All right, when you've done that, we will go ahead and test our predictions with a truth table, because that is how we're going to tell whether the statements are equivalent or not, right? Same truth values for all possible combinations. There are two simple statements, P and Q. Then we're going to go ahead and look at if P then Q. And then on the next one, we'll reverse the order and see what happened. And then I'm going to go ahead and negate P, negate Q. And then we'll look at if not P, then not Q. And then we're going to reverse that order and look at if not P, if not Q, then not P. Now, there are two simple statements, so we know that there are four possible truth combinations. True, 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 false, false, true, and then false, false. For the conditional statements, if true, then the statement is true. If true, then false. If the hypothesis is true and the conclusion is false, then the conditional statement is false. That's the only time that that's going to happen. If the hypothesis is false, anything goes, so both of those are true. Now we are going to reverse the order now. So if Q, then P. So Q is now your hypothesis and P is now your conclusion. What happened when we switch the order? Are they still the same? Meaning, are they logically equivalent? Well, let's see. If Q then P, if true then true, the conditional statement is true. If false, if the hypothesis is false, the conditional statement is true no matter what. So far, it doesn't look like if we switch the order, they will be equivalent. Let's continue the truth table though. If true then false, then the conditional statement is false. If false then false, the conditional statement is true. So as we can see, blue is not the same as yellow. What happened when you switch the order of the conditional statement? They're not the same. They're not logically equivalent. So blue must be equivalent to one of the other ones, right? And yellow is going to be equivalent to one that is left. All right, now let's negate P. That would be the opposite truth value of whatever the P column is. And then negate Q. That would be the opposite truth value of whatever the Q column is. All right, now if not P, then not Q. We're going from left to right there. False implied false is true. False implied true is true. True implied false, however, when the hypothesis is true but the conclusion is false, then the conditional statement is false. Lastly, true implied true is true. Now we're going to go from right to left. If false, then the statement is true. However, if the hypothesis is true, then the conclusion is false, then the conditional statement is false. If false, anything goes. So that would be true. And then if true implies true, then it is true. So as we can see, the original conditional statement, if P then Q, is equivalent to not Q, then not P. So switch the order and negate both. Okay, and then the yellow and the red are equivalent. And you can see, switch the order and negate both. So then again, let's summarize what we saw. Blue is equivalent to green, and yellow is equivalent to red. Okay, now let's actually give names to these statements. If P then Q, we call that our conditional statement. If hypothesis is P, the conclusion is Q, then when you switch the order, if Q then P, that is defined as the converse of the conditional statement when you switch the order. Now, when you negate P and negate Q, if not P, then not Q, we call that the inverse. And lastly, the contrapositive is when you switch the order and negate both simple statements. So if not Q, then not P. And from previous truth table, we have demonstrated that the conditional statement is equivalent to is contrapositive. Now, what is a contrapositive? Is when you switch the order and negate both. Okay, so the converse, if Q, then not P, if you switch the order and negate, that is contrapositive. So they are equivalent. Okay, so the converse and an inverse are equivalent, whereas the conditional statement is equivalent to is contrapositive. And that is a very, very, very important learning point, because we are going to be able to use that when we are evaluating arguments. We are able to name the common arguments that are valid and those that are invalid. Okay, so again, logically equivalent means they have the same true values for all possible combinations. And then a conditional statement is equivalent to is contrapositive. That is, if P then Q is equivalent to if not Q, then not P. And that is that for equivalent statements.